exploring emergent complexity from simple rules, an algorithmic philosophy perspective.
Welcome to the Universal Principles podcast. Today, we're diving into the fascinating idea of emergent complexity from simple rules. It's the observation that surprisingly complex stuff can arise from very basic interactions. I'm excited to learn how this plays out in the world of algorithmic philosophy. What does this principle mean in your field?
Thanks for having me. What's captivating about emergent complexity is how it helps us understand big philosophical questions through computation. We're talking about simulating things like consciousness or morality using algorithms. If you boil down complex behaviors into a few simple rules, then run a simulation with thousands of agents interacting, you can witness incredibly complex and unpredictable outcomes. It's the higher concept of simplicity giving birth to complexity.
That sounds mind-blowing. Could you walk us through a concrete example?
Absolutely. Think about simulating the evolution of moral systems. We can create agents that follow a few simple rules: cooperate, defect, punish cheaters, and so on. When these agents interact, surprisingly nuanced moral codes can emerge. Groups might develop strong cooperative norms, while others fall into cycles of betrayal. These outcomes weren't programmed directly, they arose from the interactions of the simple rules. Ready for another?
Definitely, I'm hooked. What other examples showcase this complexity arising from simplicity?
Consider modeling the spread of information or misinformation online. Each agent might have simple rules for sharing content based on factors like source credibility and personal biases. When you simulate millions of these agents, you can see how echo chambers form, how rumors spread like wildfire, and how polarization intensifies. It's emergent behavior driven by a few basic sharing rules. Fascinating and a little scary, right?
Absolutely, so it's not just philosophy. Where else do we see this principle in action?
Well, systems biology offers a striking example. Emergence itself is used to describe how simple biological components interact to give rise to complex living systems. Think about how individual cells, each with its own limited set of instructions, work together to create a whole organism.
That's amazing. Now, for those listening, what are some practical ways they can apply this principle in their own lives or fields?
Great question. First, start small. When tackling a complex problem, break it down into its simplest components. Second, run experiments, simulate interactions using models or even just thought experiments to see what emerges. Third, embrace the unexpected. Be open to the surprising outcomes that can arise from simple rules interacting. Don't try to control everything. Let the system reveal its own complexity. This can revolutionize your thinking.
That is fantastic. You've given us a lot to think about. Any closing thoughts on emergent complexity?
Just that recognizing this principle can transform how you approach complex problems. Don't always look for top-down solutions. Sometimes, the most elegant solutions arise from the bottom up. Thanks for having me. It's been a pleasure.
And thank you for shedding light on emergent complexity. And to our listeners, join us next time on Universal Principles, where we'll unpack another fascinating idea.